Day 12. I do this every time. 3 tries. Here we go. Day 12. A nice short day. We're, again, a lot of this is just implying derivatives and how we can think about derivatives, which you guys are smart kids who already know how to do derivatives. So a lot of this is like, okay, I pretty much get that. We're basically going to make 3 charts. So we're going to title this When Looking at f of x. We're going to draw a graph. We're going to label it f of x. And then we're going to make a little chart. I guess the chart should be a square, cut it in half, 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 cut it in half. 4 by 4 square, 16 boxes. And I get to cheat and make it extra nice. Not too bad. In our box here, we're going to put f of x, f prime of x, f double prime of x. I watched an IB video and the guy was saying f dash x and f double dash x.
That is not a dash.
I was like, yuck. I mean, he was British, so already gross, but just kidding. Then at the top, we're going to put greater than 0, less than 0, and equal to 0. And so this is just, again, things we should already know, but let's just write them down and make it so that we don't goof any of these questions. Looking first at f of x, looking at the graph, how do we know when f of x is greater than 0? Great. Above x-axis. And less than 0, same thing, below the x-axis. Of course, it is above right here, and it is below right here. Okay, cool. What about when it's equal to 0?
Solution.
Right, but where is it on the graph? It's an x-intercept. Now that one is, even a algebra kid could be doing that. First derivative. Now, we're looking at f of x, the first derivative. When is the first derivative positive? Whenever this graph has a positive slope, I'm just going to put increasing. Right? Whenever this graph is increasing, we know that the derivative is bigger than 0. When is it less than 0? Of course, there's the same thing, just opposites. Decreasing. And when is it equal to 0? Maximums, minimums, flats, stationaries, extremas. I don't really know, right? All the same. Max, min. And when is the second derivative greater than 0?
When the slope is increasing.
No. Well, are you saying when the slope of the slope is increasing?
Yeah.
Well, that's too complicated to think about, really. Simply, starts with the letter C. Concave up. Maybe somebody said that. Sorry if I didn't hear you. Concave down. And when is f double prime equal to 0? The point of inflection. Now this one can be tough to spot. This can be tough to spot. You just kind of almost do the like, this is certainly concave down, this is certainly concave up, in between, then maybe it's right here, right? It's just, if they're gonna expect you to look at a picture and say what it is, it's probably gonna be something like, you know, this is A, this is B, and this is C. Which one is the point of inflection? You say, oh, it's B. Cool. That, pretty straightforward. Now, one of the most fun types of questions that I think when I learned this, I was just in AP Calculus in a class of like 20 or 25, and we were all good students. You know, we all did pretty well on the exam. But this was one of those things where there was a few kids in class, they just couldn't figure this out. Always made me feel pretty smart when this was super easy. However, it always surprised me that there's a kid or two who kind of can't quite put their finger on this. So we're gonna draw a picture. Now, to be clear, this is not the direct derivative graph of that other graph. This is just the same graph again. But this time, let's label it, oh, not double prime, not double dash. And then let's do the same thing. F of x, f prime of x, f double prime of x, greater than 0, less than 0, equals 0. So what we're looking at right now is the graph of the derivative. So we're kind of already looking one level up. We're kind of on that fourth plane of existence right now. Okay? So now, because we're talking about f prime, let's just start on the f prime column. Okay? How do we know when the derivative is greater than 0? When it's above the x-axis. That's right. And so, of course, below the x-axis. And how do we know when the first derivative is equal to 0? When we have an x-intercept. And what about our second derivative? How do we know when that is positive? When the slope is increasing. When the slope is decreasing. And how do we know where our f double prime equals 0 is, where our point of inflections are?
The minimum maximum.
Yes. So when we do this, our table is different from the last one, but our table is also kind of the same, right? We're just one level into the future. We're one level on a higher plane. When we're looking at the graph of the derivative, can we go back in time and think about f of x? What do you think? Not really.
How would you know what the constant is, right? Like if you were looking at the equations.
Not really, correct. Imagine, just for a second, imagine our original graph. It's a nice U. Then our first derivative is going to be constant, something like that. If we're looking at this, can we go back in time and look at, hey, where was the minimum value? No, this just looks like a, nice line the whole time. So you can't really, if you're starting, on level 2, you can't really go back in time to discover, to imagine what's going on on the first level. I do want to write down here we know all this kind of stuff, but when does a max happen? You guys have to go at 9:30? I've literally got this much on the next page, so is that cool, you think? 2 minutes? When does a max happen? When the first derivative is going from increasing to decreasing. So on this graph, when does it happen? This? You're saying?
No, isn't this the maximum? Or you're just asking what the maximum is?
Where can you find the maximums? If we're looking at f prime, where does f of x have a maximum? Where does the original one?
Infinities,
Or would it be the x-intercepts, because the x-intercepts are the one above the maximum min for...
So if we're looking at f prime, we're looking at the slopes, and when the slopes are 0 is when we have x-intercepts. So here is where we have maximums and minimums of the original f of x. Now, how do we know which one's a maximum and which one's a minimum?
you look at the slope before and after, right?
Right. Well, no, you look at the y value before and after, which is the slope in the other realm. So which one of these, if I label these A, B, C, which one of these is a maximum? Or which two of these are maximums?
B, right?
Well, we got an A answer and a B answer. Remember, a maximum is increasing and then decreasing. So we need to be on the positive y values and then changing to the negative y values. So that means a maximum is whenever we go from above to below. Whenever we change from above the graph to below the graph, that is making a maximum. So that would be like value B is where we have a maximum. And of course, the opposite is true. From below to above. That's whenever we were going down and then we were going up. Sweet. And you guys got to go, maybe as you're packing up, just look at this. I'm going to give you a piece of paper, yes. When looking at f double prime of x, and we have a graph, and we do the same thing, f double prime of x. F of x, f prime of x, f double prime of x, greater than 0, less than 0, equals 0. When we're doing this, when we are looking already starting off, here they are under my thing. Again, you can't really just like pluck information from those levels before where we are now. So this much of the table, we can't really get much from that. And of course, this would just be above the x-axis, below the x-axis, and then this would be at x-intercepts. So on that piece of paper that you guys just got, and here you guys go as well, it's basically just a whole bunch of questions where you get to look at a graph, and you might be looking at the graph of f, you might be looking at the graph of f prime, you might be looking at the graph of f double prime. You might have to draw the graph yourself, given one of these, given one of those. And so we're gonna be kind of drawing this, sketching this out. If you guys are good, packed up, good luck today. Are you guys, when do you guys expect to be back today?
5:30.
5:30, 6 o'clock? That is a day of hard work, no doubt about that. You guys gonna be on TV too?
Yeah.
Sheesh.
What's the channel?
I have to find out.
Well,
It's like PBS, isn't it?
Make sure you
McDonald's
text
and
me.
Fries.
Send it to me, bro. Watch it at school. You're gonna see
we'll do a game analysis, performance analysis when you guys get back.